Let's take a look at how to factor this polynomial completely. So the polynomial is x to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 10x plus 10. And they give us a root. They give us that root 2i is actually a root. And so we have to factor this. Now we know that complex roots actually come in pairs. So if root 2i is a root, then so is negative root 2i. Multiplying out x plus root 2i times x minus root 2y gives us x squared plus 2. We can now do polynomial division, where we divide our original quintic polynomial by x squared plus 2. But this is going to start getting gross. We're saying x squared goes into x to the fifth, x to the third times, and then you multiply x to the third by x squared plus x2 and cancel stuff out, but you're going to get missing terms, and it's going to get kind of gross here. And if you're not careful, you can make mistakes, and things going to kind of fall apart. And it's very easy to make a mistake here. In fact, I make a mistake when I'm writing here, and I get frustrated. I'm like, I don't want to do this. So let's try another way. So I'm again going to try to factor this quintic polynomial, but instead of factoring by finding a root and dividing by the polynomial, I'm going to factor by grouping. Notice here that the first two terms both have an x to the fourth in common, so I can factor out an x to the fourth. The second two terms have a negative 3x squared in common. I factor that out. And in the last two terms, they have a negative 10 in common. I can factor that out. And then what's left behind in all three of those cases is an x minus 1. So that means I can factor an x minus 1, and I'm left behind x to the fourth minus 3x squared minus 10 times x minus 1. And we can actually factor this trinomial. I'm going to break the negative 3x squared up into negative 5x squared plus 2x squared, and I'm going to factor by grouping again. I factor an x squared out of the first term, and I'm left with an x squared minus 5. And I factor a 2 out of the second term, and I'm left with an x squared minus 5. Factoring out those x squared minus 5, I get x squared plus 2, x squared minus 5, and x minus 1. And if you want to go one step farther and find the roots, you get that the roots are 1 plus or minus root 5 and plus or minus root 2i.